be given to you in the question. And then we're going to have the expected data, which you need to calculate using your calculator. This is quite an easy step, and we will go through it step by step. The observed is what is given in the actual experiment, whereas the expected would be what would be expected if this was a normal distribution. So if it was all nicely and evenly balanced out, what would you expect these results to be? Basically, if we have a table of values which have 4 numbers here, and these 4 numbers here match up completely, we get chi-squared, which is this, to be really, really small. And therefore, the observed and the expected match. If the observed, these 4 numbers are very different to the expected, then chi-squared will be big. If chi-squared is big, this means the data will have an effect on each other. So effectively, we've got another point we need to make. The closer it is to 0, the closer the model compares. This is in terms of the observed and the expected. So the observed is what's given to you in the exam. And also, if the models are very similar to each other and they're very balanced, you can say that the results are independent of each other. This normally happens when there's no real sort of difference in the table. When the table looks quite similar, all the numbers in the table look quite similar to each other, we're going to say they're independent. Whereas if chi-squared is very large, we are going to end up saying the data does depend on each other, and this is because the expected and the observed are very different. So there must be something which is causing this pattern in the table and this difference between the observed and the expected, and therefore the categories are going to really depend on each other. I would like you now to spend a couple of minutes writing down anything I've just talked about and making notes. So next we're going to talk a little bit more about the observed and the expected. So observed, remember, was the first table on the last slide, and then expected was the table we would get if we applied the normal distribution. We're going to talk about, first of all, how to get the expected data, which is our answer for these questions, using the observed. And we're going to do this by using a method without the calculator, or without the TI-84 calculator, and then we'll do one with the calculator. So this is without the calculator. Now this will be relevant for many of your IAs. So although we won't be doing any questions on this part of the video is essential. So this is the table we are given in the exam, for example. This is going to be the observed data. It would represent different values for males and females studying different topics within a particular cohort of students. The first thing you'd have to do, if not already done, is calculate the totals of each row as shown by this green rectangle, and in addition to this you'd have to calculate the addition of each row using the blue box. I made an error there. Please can you work out what error I made? Hopefully you noticed I meant to say these were columns because these are going vertically down the page, and these are rows. So in order to find out the expected numbers, what you have to do is you have to get the column total, times it by the row total, and then divide it by the overall table total. So to find the new value, which is 8, we have to do 20, which is this number here, times 40 divided by 100. Therefore, to find this 12, I'm going to do a similar process. We're going to do 20, but this time 60, because we're talking about the females, divided by 100. So this is going to give us this value of 12 here. And then we would keep repeating the process. So for ANA SL, we would do 45 times 40 divided by 100, and that's going to give us the 18. So you will have to do this if you're doing chi-squared in your IA. Now I'm going to show you how to do it with the calculator. This data represents people who exercise and don't exercise, and whether they're male and female. We're going to be studying the main part of the table. The main part of the table is going to be this section here. You can see it's going to be a 2 by 2 grid because we exclude the sum column and row. So bear that in mind for the next step. Here are the steps, and I'd recommend we pause the video and you write these down in a moment in your own words. So going on to the TI-84 calculator, I'm going to find the matrix button. The matrix button is quite nicely located above the x to the minus 1. So clicking on that, I'm going to press second x to the power of minus 1. Now I would like to edit a particular matrix. So we're going to go across and we're going to edit one matrix. A matrix is just numbers in a grid or in a table as follows. In university, you'll be able to manipulate these matrices. However, at this level, we do not need to do anything much more to it. So once we've put in the data, which I've already done before, you need to press enter. And each of these numbers will go in one by one. Now, if you go back to the matrix menu, you can see that I can now observe what I've put into A. So if I press number 1 and enter, you can see that A is going to have these values 112, 104, 96 and 88, which matches with this. But what we want to actually do is we want to work out what the expected table is going to be. So this is our observed table, but how do we work out the expected table? So with this one, we have to go into stats. We're going to go across to tests. Today we're doing t-tests, so you need to go right to the bottom. And before we do t-tests, we'll do that another lesson, we're going to do the chi-squared test, which we've already written down is this fancy x to the power of 2. Going to press enter. This means we want to put the observed in matrix A, which we've already put in. The expected is our outcome in matrix B. We're going to press enter several times, and then it works out our chi-squared statistic. We'll come back to that later, but the reason why we did this is because if you press second x to the power of minus 1, we can now view what our expected data is going to be. We press number 2, and then we press enter, you can see this is our expected table. So in the exam, for 2 marks, they might ask you what is the expected values. You can either use this method we went over, or if you think it's quicker, you should use this method, but it's advisable you use this method. Now, we're happy with how to do that with a calculator and without a calculator. Now, what I'd like you to have a go at is work out what the expected matrices are going to be for each of these 4 examples. Then we'll come back and we'll discuss which table was different to all the other ones. There may be more than one answer to this. So you've got 4 questions to do. We now need to pause the video and continue with this work. Continuing on now, we want to talk about the chi-squared statistic. So this is our observed and expected from before. This is going to be our chi-squared statistic formula. Now it looks complicated, but it really isn't complicated. I would like you to copy down this formula now and pause the video. Welcome back. I'm going to talk about each part of this formula. The first thing we need to think of is this weird sign here. Now, if you haven't seen this before, this means sum. So that basically means you're going to repeat an operation so many times and then you're going to add it together. This means f 0, this means the observed frequency minus the expected frequency divided by the expected frequency. So let's go over the first fraction. Again, if you were doing your IA, you would have to do it this method. We're going to take the observed, which is 5, which is why we've got a 5 here. We're going to minus the 8, which is where we've got an 8 here, and then we're going to divide it by 8. That will give us the first step of this calculation in calculating chi-squared. We need to repeat this step 6 times. Can you pause the video and explain or have a think about why we're repeating this step 6 times? Excellent. Hopefully you noticed the reason why is because we have 6 entries in the table. So we need to repeat the process for 15, comparison to 12, 15 to 18, 30 to 27, 20 to 14, 15 and 21. This will give us what we call the chi-squared statistic. Now, like I said, the closer these match to these, the smaller this will be. So let's show you how you'd actually do this on the calculator. So this time we need to repeat the process on the calculator, but for our new table. So our new table is slightly different dimensions. So we're going to go on to matrix, we're going to go across to edit, we're going to go into A, we're going to change the dimensions this time to 3 by 3. We're then going to go into table, and now you're going to pause the video and work out what mistake I have made. Hopefully you noticed the mistake was the fact the table's not 3 by 3. The first number you've got to write in is the rows, and the rows in this particular table on the right hand side is only 2, and the columns are 3. So we need to write down 2 instead of 3 for the first number. 2 by 3, enter. It's now altered the table for us. Now we're going to put in the observed values. I'm just going to copy in 5, 15. Notice when you press the right arrow, it tends to go down. 15 again. 30, 20, and 15. As before, we are going to work out what the expected matrix is. So I'm going to go into my tests, find that using stats, go across to tests, go down to chi-squared test, press enter, observe A, expected B, calculate. Let's just check our matrix is correct. Second matrix, let's enter on B. 8, 18, 14 matches the top row, 12, 27, 21. Great. Now we're going to calculate the chi-squared. So you may have seen I've already done this. So if we go back to the start menu, go across to tests, go down to chi-squared test, which is C, press enter. There we go. Our answer is 6.994047619. And in the exam, they might ask you the degrees of freedom. We've talked about how to do that without the calculator. And we've also got the letter P. Now, we're going to visit that next lesson, because for some of you that will be a little bit complicated. So now we have to decide for our final step whether to accept or reject HO. HO is one of our arguments. If we accept it, what happens is that the variables are independent. This is because chi-squared is small. If we reject HO, this is because they are dependent. For example, we're going to compare it to a critical value. The critical value is not going to make a lot of sense to you today, but we'll go into it in more depth next lesson. The critical value is something we need to compare to the chi-squared. So it might be given as 5% in the exam question, and we need to compare it with a chi-squared value. So continuing on with this question then, we would have calculated chi-squared to be 6.99. You can see on the calculator, and you can see in the non-calculator method we calculated it to be 6.99. Now we're going to do the comparison. Chi-squared is 6.99. Now let's say in the question it states the critical value is 5.99. Now what you have to do is you have to compare the 5.99 to the 6.99. So what you do is you write an inequality comparing the two. We're going to say that 6.99 is bigger than 5.99. And effectively, if we get that chi-squared is bigger than the value given here, which we call the critical value, what we're going to do is reject. Now, if it's the other way, if the critical value is bigger than chi-squared, we're going to accept. Now, there's going to be a step-by-step process I'm going to share with you, and that's going to be useful for the next steps. This is our step-by-step process. First, step 1, we're going to just state the null hypothesis and assume they are independent, and state that H1 assumes they're not independent. Step 2, we're going to calculate the degrees of freedom, which we did for the starter. Step 3, we're going to copy from the question the significance required. Step 4, we're going to state the rejection inequality. So in our other question, we had that we needed to study with the value 5.99. So what we need to do is we need to compare the 5.99 with the 6.99. We then need to enter into your calculator in the matrix. We then either need to write we accept or reject HO. Step 7 will come on to next lesson. So I'm going to leave these on the screen for you. This is what you need to do for every question. Best of luck, and let me know if you need any help.